Good morning, class. We're going to be talking about section 4.6 and 4.7 today. And on Monday, we'll have the quiz over sections 4.4 through 4.7. If you have any questions, feel free to ask them today. We're going to be talking about direct variation and graphing linear functions. Direct variation should come pretty naturally to us as we're covering this, but again, if you have questions, this is the time to ask it. Okay, direct variation is actually going to be easiest to understand if we assume we have a y-intercept of 0. Now what is our equation for a line? Our equation for a line using slope-intercept is y equals mx plus b. Okay? Y equals mx plus b. Now, if there is no y-intercept, then what we would get, y equals mx, right? Because if b is 0, you just add 0, you just get your original. So direct variation actually looks identical to this, but they use a different letter, okay? So the letter doesn't change anything. Just assume A and M are the same idea, okay? So A equals M, assume that, right? So if A equals M, sorry about that, if A equals M, then what we're gonna get is what's our new equation if we had A equal to M? Well, then we would have y equals ax, right? Because we could just replace what's equal, okay? This is direct variation. If one thing is true, if A does not equal 0, okay, if A is not equal to 0, we have direct variation. Direct variation means as 1 changes, so what happens as x grows? Okay, well, we'll look at some cases. What happens when x decreases, okay? Okay, constant of variation. So constant means it's a number. So basically, think constant variation, something that isn't going to change. So A is our constant of variation. Okay, our constant of variation is A. Or you could say something up here. You could say y varies directly to x, or varies directly with x. Sorry about that. Running out of space with it makes it more difficult. Okay. Varies directly with x. Okay? So, let's look at identifying if it's direct variation or not. Okay, so again, direct variation is a line that has 0 as its y-intercept, okay? Meaning you're not going to see a number for a y-intercept. Okay, let's look at this. Okay, example 1, so we have two examples. 2x minus 3y equals 0, and negative x plus y equals 4. Now this first one, what we're going to do is get x to the other side. So we get negative 3y equals to negative 2x. Right? And then we're going to divide both sides by -3, dividing by -3, we get y equals to 2 over 3. Right, because these two are negatives. I just subtracted over here. Okay, so I subtracted the x over, minus 2x. That's how we got negative, and then divided. Okay, now does this have no y-intercept? Yes. Okay, no y-intercept, right? This is a 0 right here. We can't see anything. So that is direct variation. Okay, direct variation. Okay, what else is true? If it's direct variation, what's our constant of variation? Well, what is the only number we see in this equation right here? 2/3. So then the constant of variation is gonna be 2/3. Okay, what about this one? Okay, so we add x to both sides, and we get y equals to x plus 4. Do we have a y-intercept? Yes. So this is not direct variation. Okay? And that's it. You're done. Okay? So if it is direct variation, you have to find the constant. If it's not, you're done. Okay. Well, so let's continue on this page. Okay, there's some examples below. We might try practicing some of these in our quiz and class. Okay, direct variation graphs. Note that the equation y equals ax is a linear equation with slope-intercept form. M is a, yeah, basically that's what we talked about. Okay, y-intercept is, yeah. So, when graphing this is a pretty easy graph actually. This is kind of my favorite graph. Okay, let's say we're graphing this line right here. That's direct variation line. What do we know about its y-intercept? Well, if you look at it, does it have a y-intercept? No, so it then always goes through the origin. So we start at the origin, and we're going to plot 2 up, 3 to the right. Or you could do it if you want, you plot 2 more points. Alright, 2 down, 3 to the left. Because it should be a consistent line. And then you draw your line through these points. Okay, and there is your direct variation. This is y equals 2/3 x. Okay? Okay, what about negative? Well, another example. It's okay. Okay, let's look at one more example. What if we had y equals to -3x? Now remember, slope is rise over run. So it's change in y over change in x. So our change in y is down 3 as we go to the right 1. Because -3 is just -3 over 1. Okay? So we go down 3 to the right 1, and then we draw a line through those 2 points. Okay? And there's our line. Okay, now, do you only need 2 points for our graphs? Yes. Okay? You only need 2 points for our graphs. Okay? Okay. We're almost done with this. So last one, we're going to talk about finding the direct variation. So they give us 2 points. They give us -1, 2, And we can see by their graph on this page that we also go through 0, 0. Now, what's our equation for slope? Our equation for slope is m y2 minus y1 over x2 minus x1. Okay, you're going to need to memorize that formula. It should be embedded in your memory. We'll choose which one we want to be y2, x2. So this will be y2, x2. So we'll do m equals 0, 0 minus 2 minus negative 1. So the top is negative 2. So negative 2 on top, bottom, positive 1. So our slope is negative 2, so y equals negative 2x because we crossed the y-intercept at 0. So that's our line. Then they say so this is part A. Part B is find y when x equals 30. So we get y equals negative 2 times 30. Y equals negative 60. And that would be our answer. Okay? Okay. So that is part A and part B of that. Properties, slope is A in this. Direct variation equation passes through the origin, 0, 0. Yeah, don't worry about that. Ratios, direct variation can be written as a ratio. Basically, if you wanted to solve for A, remember when we had literal equation, if you want to solve for A, you just divide both sides by x, right? So y equals ax. You wanted to solve for A, then you divide both sides by x. So y over x equals A. And look at that, we have a new ratio, okay? Okay, that's gonna be it for this class. Then we'll have the next video.